But without further ado, I want to bring up Karl from nuTonomy, which is arguably the best known self-driving software startup. You have an academic background. Can you talk a little bit about what led you and your colleagues to leave 4 years ago? I think someone told me at some point you started as maybe a consultancy or consulting firm, but what actually triggered your departure to start a company?
Well, I mean, it was really the opportunity. It was seeing the possibility to transition some of the things we've been doing at MIT to a larger scale. I loved being at MIT. It was a great job. I loved coming in on Monday and knowing what was going to happen Tuesday, Wednesday, Thursday, and Friday. But then at some point, I kind of hated that. You'd come in on Monday and you'd see everything that was laid out in front of you, not just that week, but for the next years. And so, the biggest my lab ever was at MIT was 25 people. Now at nuTonomy, we're going to be 150 people by the end of this year and doubling in size over the next year after that. And so it's just a chance to make a much bigger impact with the technology. So it was that, but also, I think us as a community, 3-4 years ago, you could squint at it and you could see that this technology that for a long time, which is a science project, is just about ready for the road. So we started the company, our initial goal was to get our software integrated with OEMs and maybe be part of a feature. And we quickly realized that the opportunity beyond that is much, much larger, to have our cars on the road in every city worldwide as part of fleets.
So how many of you are actually MIT grads or formal faculty at the company right now?
Well, we like the people from MIT. I mean, but not everybody, of course, can get in, so we can't hire everyone from MIT. We have everybody, we've got 20 nationalities and probably 40 different universities. So we recruit hard for MIT because it's in our backyard, but we welcome everybody with a good idea.
And what's the capital environment right now for teams with really good PR and actually cars on the road and all the attention that you've gotten? How easy is it to raise money at the moment?
Well, I mean, the biggest question is deciding when to raise capital, how much to raise, and who to take it from. The hardest problem at the end of the day usually becomes allocation, not actually scraping up the investment. There's a lot of money and interest in this space, for better or worse, in AV in particular, and what we're doing in nuTonomy, also. So it's not something that's on my top 3 list of worries. Let me put it that way.
Well, what kind of valuation do you think makes sense for a company like yours, that is maybe a year or more away from kind of commercialization, as you put it?
I mean, everybody's going to have their own answer to that question. You look at the size of the addressable opportunity, and it's huge. You walk back a few steps on what you need to do in order to get there. Obviously, there are steps along the way. You raise at a level that you think is appropriate, something that's supportable through the next round, something that allows you to fuel your activities. I don't think there's a single right answer there.
Okay. So, there are a bevy of press releases and announcements, generally around partnerships that come out on pretty much a daily basis around the world when it comes to self-driving cars. What percentage of those announcements are vaporware or head fakes or, just kind of stabs in the dark?
What percent?
Yeah.
I mean, 37.4. No,
okay.
I don't know. It's hard to say, but I think, I believe partnerships are meaningful. I think establishing the right constellation of partners is critically important. For us, it's essential. I mean, we're a software company. We need to get to market through partnership. Mm-hmm. And establishing those early on is very important. Let me put it this way. I'd much rather err on the side of establishing them earlier than later, because building that relationship, those relationships gain ballast over time. So we're trying to put together the right relationships in the right cities with the right companies worldwide so we can address some of the key early markets in this space.
Yeah, and I wasn't talking about your announcements, obviously.
I had no doubt.
But before we get back to some of those partnerships, can you talk a little bit about what is the hardest part of an autonomous vehicle system? I'm sure everyone will have a different answer, but what's your view?
Well, from a technical perspective, I think people would generally say there's probably 2 hard areas. There's perception, and then there's the decision-making, the brain. I lean towards saying the decision-making, is the harder problem if I had to choose one. And to add to that, the thing that's really hard about it, it's hard to get it right the first time, and it's really hard to scale it. I think as an industry, we've been through sort of 3 phases. There was the first phase where we were just happy to get a car on the road, quite frankly, to convince ourselves that it could work, that it could drive around the block in this kind of slot car mode, all right? And then I think we're pretty much now in this second phase where there's a number of players that are in beyond slot car mode, are in sort of feature development and kind of toward validation, let's say. Nobody's really validated yet, but sort of toward validation. But the next stage that's coming is the really hard one, the really interesting one, which is scaling. I mean, if you develop a system that works in one city, nobody cares. I mean, nobody cares. You can make a little revenue in that city, but you haven't built a multi-billion-dollar company. You haven't really addressed the opportunity.
I want to get back to that in a second, but can you talk a little bit about why the motion planning and the part that you have researched for a decade or more is the most important piece? And you know, there are, I think maybe somebody in this room is a bit biased, but they come from kind of a hardware background, a sensor background, and they believe that, you know, the hardware that we have on the test vehicles today is crap. Mm-hmm. And it's nowhere near what it needs to be. And so if the hardware were a lot better, if the sensing were better, if you know, we could collect more data, if the cars could collect more data about what's around them, the software side gets a lot easier.
Well, it doesn't ever get easy, though. And there's a knob you can turn around speed and complexity of the environment, which can take some of the pressure off the hardware. The decision-making, the brain of the car, you know, you have to make hard decisions on the road in any driving environment, and also every city is different. So I can tell you, I can assure you, when we went from Singapore to Boston, mm-hmm. driving from the left-hand side to the right-hand side, it's a massive change in your, potentially in your architecture if you don't think about, from an architectural perspective, developing a scalable system from day one. So every decision we make at the company today is thinking in terms of scalability. How will this impact not just on the road in Singapore, but in Singapore, in Boston, in San Francisco, in London, wherever else we end up? Because again, the single city solution, if you're, you know, tuning parameters and applying patches and making little fixes just to get it to work for that one city, well, I mean, good luck taking it to the next city. You're going to have a very difficult time.
Well, that's not a terrible business either. If you own Singapore, if you nail Singapore, that's not a bad business, right?
Well, I mean, if you're happy, you know, making $100 million in Singapore, yeah, sure. But the bigger opportunity, I mean, it's such a greater opportunity out there. I mean, the big winner in this space is not someone who's going to develop a car that works in one city. It's going to develop a car that works in every city. Maybe not tomorrow. We're not going to be in New Delhi tomorrow, but someday we will. And the emphasis on having a scalable approach, I mean, I can't overemphasize, one, how difficult that is, but two, how important it is.
But you are saying that, you know, the learnings that you get from Singapore are applicable elsewhere or not really applicable elsewhere?
No, I mean, they absolutely are. But I mean, look, I think we're going to look back at this phase in the development in the industry and with kind of basically with awe and horror. We're doing everything by hand. You know, we don't even have tools that are industry kind of, you know, commonly accepted. Everybody makes their own tools. Everybody makes their own simulations, mapping, everything from scratch.
And they don't talk about it, so we don't really know what they're doing.
Yeah, but it's kind of like, you know, you see a 15th century clock, and you're like, my God, they made all this complex machinery just to tell time, but it worked. And so we're going to get something to work, but we're going to look back with amazement that we went through all this meticulous, painstaking work to get it to that point. The better approach will be to have more, I don't want to say automated per se, but rigorous and systematic approaches to developing the software, to be able to go from specification to automated generation of software, and then, oh, by the way, we've got verified software coming out the other end. I mean, that's what we're trying to build in nuTonomy, which is really hard, but I think that's the way we have to go as an industry. That's where we're going to need to end up.
Well, what's the deal with, or can you talk a little bit about this RRT architecture or algorithms that you have, and why they're so important, and is there industry consensus that, you know, the use of those algorithms that you've researched is kind of the way to go?
Well, I mean, you're referring to RRT Star, which is one of our planning algorithms. We have, I would say, a unique approach to planning and decision making that we think is the right way to solve the problem. It's, you know, at the end of the day, it's a little bit closer to the aerospace model than it is the traditional automotive model. But I'm of the belief that, again, when we look forward 10 years, 15 years, you know, the certification and validation procedures that we're going to be using are probably a bit closer to those used in aerospace than they are in automotive today. I mean, that's the bet we're making.
So on that thread, there's certainly kind of a growing interest in the concept of shared control, and maybe more some of the concepts that perhaps come from aviation, where, you know, for example, if you are in a car and you want to, you know, go into another lane and there's a car there, maybe the steering wheel, since the car knows that there's a car there, won't let you go there. Maybe it'll be really hard to turn that wheel and get into an accident. Is that kind of the direction that we're heading into?
I think it's an application. I think it's a nice feature for some OEMs. I can tell you it's pretty hard to do that right. I spent about 5 years of my life working with one of my students a kid named Sterling Anderson on that exact problem, shared control. And the one sentence takeaway is that this is hard to do and guarantee stability. You probably shouldn't do it. That could have been the subtitle of his thesis. You probably shouldn't do this. But, you know, he went off and did autopilot, so God bless him.
Okay.
But it's not easy. It's not easy to do it right, let me put it that way.
So he's referring to the person who's now working with Chris Urmson at Aurora Innovation, right? So he was your student, you said?
Yeah, one of my former students.
Got it. I'll ask you more about that later. So, you know, we don't have enough time to talk about it in great detail here, but the words deep learning come up on a daily basis when it comes to developing self-driving car software, and you know, we'll have Carol up here later, hopefully talking a bit more about that. But there's a lot of controversy in the sense that, you know, people who have been working on these problems and worked on the DARPA Grand Challenges have very kind of specific views and critiques of using too much of that type of machine learning as part of a system. Can you sort of elaborate a little bit on what issues you have, how you see it being applied by various companies today, and what issues you have with that?
Well, we use it quite a lot. I mean, we use it in our perception stack all over the place. And you know, for decision making, for kind of the AI, the brain, whatever you want to call it, I mean, it's immensely appealing, right? You just teach the car how to drive. But for me, the two big problems that I can't quite get past relate to traceability and induction, right? I mean, traceability, you want to be able to go from a specification, why did the car do what it did? I need to be able to answer that question in a rigorous way. And then induction, I mean, it's a classical AI problem, right? I mean, AI learning systems of any stripe are very good at recognition. They can recognize scenes that you've shown them in the past. It's very hard to generalize. Let me show you something new, and you do something smart in that scenario. So then, you know, if you think about it, what is the burden there? Does it mean you have to feed the car data with every scenario it might encounter in the world, which is, you know, hard, let's say? Or you solve this really hard AI problem that allows the car to generalize beyond what it's been shown. So I don't, you know, I'm not at all surprised that a lot of people are going down this path, because if they can get it right, you know, fantastic. Could be an easier way to solve the problem. A shortcut in some sense. But, you know, again, we're placing our bet on a different approach based on our experience and knowledge of the space.
Okay. So when it comes to measuring your progress, you're talking about measurement and validation. Can you talk about what it is that you do, what metrics you track? Where are you? You know, you've got cars on the road in Singapore and Boston also, right? And can you talk a little bit about how you're doing that piece of it, how you're measuring your progress, and how other companies do it and what you've seen? Well,
we are apparently a 3 out of 5 by some measurement.
Okay,
that was a small joke. So how we measure progress.
I'm sure everyone here read all 6,000 words of the article yesterday. If you haven't, there is background on nuTonomy and all the other companies that we'll be talking about.
I mean, the obvious answer, people count miles driven as one easy metric. I mean, we see it as two axes, really. There's robustness on one axis, and then there's performance on the other axis, right? Robustness, I mean, miles driven is not a bad proxy, depending what environment the miles were driven in. I mean, if you give me a car in a test track, I'll give you 1 million miles in a week, but they're not meaningful miles. You want miles in new environments that are sufficiently rich, but let's assume that's the case. But then the more important axis, in my opinion, is the performance axis. Again, the slot car model where you can drive around in a loop in Mountain View and making only right turns, you can rack up a lot of miles driven between takeovers, but it doesn't mean your car is very capable. Capability, when we look at like a competitor's car and we say, well, how good is this team? How good is this technology? Let's try to figure it out. We just tick off what they're doing on the road, you know, negotiating intersections that are signaled, that are unsignaled, passing cars with parallel, you know, same direction traffic, passing cars with oncoming traffic. Are they maneuvering among pedestrians, among cyclists? Are they driving in the rain? Are they driving at night? Are they driving in the snow? And you kind of just tick off these boxes to get a sense of, you know, the state of play for that particular team.
So you just referenced Waymo and Mountain View, assuming that they are still the leader in the space. I mean, their cars do make left turns. I've seen it. It took a really long time. It was actually really annoying, and it made everyone behind the car really upset. But they do it. So what is it about Waymo's approach that you think might be overrated, or what have you seen, or what do you know that makes you think that maybe you can, maybe you can surpass what they're doing?
I don't think they're overrated. I think they're very good. And I don't know, Surpass, I don't have probably even as good a sense as you as to exactly where they are, because they don't let me in their car. But you know, we know where we are. We try to tick as many of those boxes as possible, and then at the same time expand our capability along the robustness axis. You want to be in the upper right, you know, quadrant of this coordinate system. So that's what we're trying to do every day.
So when you're talking to a potential recruit or talking to investors, what do you tell them about where you are in terms of how much more progress you need to make? Like what are the numbers that you use with them when you talk about where you are and where you're going to be, let's say, in a year?
Yeah, I mean, investors want to know, you know, what percentage of the way are you there? And then the great thing is you can tell them we're 97% of the way there.
Sure.
What you don't tell them, it approaches asymptotically. So that last, you know, 3% is going to require 9 years. So we don't tell them that. We show them the capabilities. We show them, what we do is we get them in the car. In Singapore, we say, well, first of all, if you want to invest, you got to come to Singapore. So you got to get on a plane. And if you pass that bar, then let's talk. And then they get in a car. And then the nice thing we can do is not just go around a loop, but say, like, where do you want to go? And they can put in a destination, and they can go on a flexible route, and they can go make turns across intersections. They can pass cars because everybody double parks in Singapore. They can see, you know, sweating pedestrians, and they don't see bikes very much. But, you know, they can exercise a lot of the capabilities we just talked about. Does it work perfectly all the time? It doesn't, and that's why, you know, we're not in the market yet, but we're getting pretty close.
Do you know when next year you'll have something?
Do you know when? That's a great, well-phrased question. Do you know when next year? Some point in next year, you know, we want to have a significantly sized fleet on the road that's moving people around as a service. So a useful
with
service,
somebody else in the car or with nobody in the car?
Very likely with somebody else in the car at that point, yeah.
Okay. But your projection on when there won't be somebody in the car?
Yeah, I mean, that's the big known unknown of the space. I mean, that's the only question today. When can you take the safety driver, as we call it, out of the car? And we have some conservative projections, some less conservative projections. I don't know that I actually know the answer. You know,
and the conservative projection is?
Well, that's a secret. And if I told you, I'd be telling you.
Really? Is it a secret? That's proprietary?
Well, you know, that's difficult, and because there's a fair amount of uncertainty around it. And so I don't want to come out today and say it's going to be, you know, March 24th, 2009, if I have a fair amount of uncertainty around it. But, you know, the question is, how do we think about validation? So we get to a point where everything works, more or less, but it has to work to such a high degree that you know, we don't know yet in the industry how many miles we have to drive, both on the road and in simulation, to convince ourselves and to convince a regulatory body that it's safe enough. Mm-hmm. That threshold will differ in Singapore than it will in the US, than it will in the UK. And so it's very much a moving target, and that contributes to the uncertainty.
And Elon Musk's prediction of, you know, 2 years, you can close your eyes and go off into the sunset and open your eyes and you're there. That seems aggressive to you or potentially right?
Well, you know, I don't know what their model is. I think they're talking about cruising on a highway. And if that's the case, then I think that's
from start to finish. From start to finish, you get in your car.
Yeah, I mean, you can close your eyes any way you want. I mean, you just gotta depends how much faith you have in the system. I think my understanding of what Tesla is doing is very much focused more on the 90% solution, the 95% solution with a pared down sensor suite. You know, the robotic taxi model, the mobility as a service model is much more the 99.999% solution, but in a restricted area. Mm-hmm. So we're not going to tell someone you can close your eyes and you can wake up in Malaysia and, you know, hop out. But no, you can go from A to B in a part of Singapore with a very, very high degree of reliability. So in terms of Tesla's model, I don't know exactly what they're aiming for. You know, but Musk is Musk.
Elon Musk would say, we're aiming for everything. We'll do it all. Don't worry.
I wouldn't bet against him, but you know, possibly it's as much trying to put a stake in the ground as anything else. Who knows?
I did want to ask you about your partnership with Peugeot, which you just announced not too long ago, but you had to sort of play the field and figure out who'd be your kind of deep partner really, really quick. What have you learned about car manufacturers in all of your discussions that has surprised you? What do you think they get or don't get about this whole area?
Well, it depends on the car maker. I can tell you there's a real appetite for partnership. I think there's an understanding much of the time that, you know, the core competence and historical expertise of the OEM doesn't necessarily align to the AV space. So there's interest among the open-minded OEMs to go out and work with companies who have built their entire business around AV. And that's great. I mean, it's a chance that I think probably didn't exist a decade ago due to the impedance mismatch between the scale of these organizations, but it does exist today.
Okay. Well, we've got a few minutes left if any of you have questions. I do have one more main question for you that I'll save. But does anyone else out there have anything to ask Karl about? Yeah, sure. Go.
Boy, that's a really big question. How do you ensure that you get a fair share of the value? And I mean, that's, within all these partnerships, that's where the maneuvering is going to take place to ensure that you capture a lot of the value, little capital in and big revenue out. And it's very much a shifting landscape. I mean, just to take one small example, not to turn this into a 20-minute answer, you look at like the ride-hailing companies of the world, where today their moat is around their driver network. They've convinced a lot of hardworking people to drive on their network, which creates a good quality of service, attracts more riders, and attracts more drivers, et cetera. When that barrier no longer exists, you can put a fleet on the road of any size, given sufficient access to capital. How do you, as a TNC, as a ride-hailing company, ensure that you're capturing a significant amount of the value? My governing hypothesis in this whole space is that the number of teams with access to the AV technology will be few, and so therefore the groups that hold access to that technology will be able to drive deals into space that are favorable for them.
I think he's asking what cut is Lyft going to take when you're operating vehicles in their network?
And my point is, if there's one AV provider, that cut will probably be smaller, and if there's many partners for them to choose from, they'll be able to have a very favorable negotiation.
Okay, so they're praying for that. Yeah, sure, go ahead.
You made a big commitment to testing in Boston, the regulatory landscape that you wanted to point.
The question is about Boston regulations and restrictions on testing.
Yeah, I mean, we love Boston as a testing site because we view it kind of as a boundary condition. Whereas, you've got, let's say, the test track, the very easy environment. You've got Singapore somewhere here, and then you've got Boston, which is frankly really tough. And we like that because you want to be able to break your system reliably, and we can do that in Boston. The regulatory landscape, it's different from city to city. Unfortunately, while around the world, certainly, unfortunately in the US, we have a really close relationship with the city of Boston. We talk with them frequently about, getting through some of these issues. Some of the stuff you read about in the news is frankly, not a credible threat. I would say some of this zombie car legislation. And so from our perspective, we're more worried about day-to-day testing. It doesn't really impact us. But of course, we try to have a voice in the regulatory conversation, and we do in Boston.
Sorry, maybe all the way in the back there.
You're on a timescale of months and years, and those guys are probably decades.
Yeah, I think the reality is that companies get to market in advance of that type of regulatory landscape being, that environment actually existing. But I think, again, we'll look back and we'll say, boy, incredibly complex safety-critical systems that are basically being engineered without clear standards around them. I mean, it's a little bit surprising. It's just because the opportunity is driving companies to move much more quickly than the government bodies can keep up with. It is what it is. And so people are going to keep doing what they're doing until somebody tells them to stop. There are certain parts of the world, certain countries that are going to be able to move more quickly. Singapore is a great example. They're small, they're nimble, they can move fast. They're going to put the regulation that they feel comfortable with in place before people get to market. If they need to update it over time, they'll update it over time. But I think eventually we get to a point where self-certification is, obviously that'll be soon, will be very important. It'll be a mix of standards from traditional auto, probably borrow from aerospace. I wouldn't be surprised if that would be the case. And it'll be, and it should be fairly rigorous. I mean, people are putting their lives at stake when they get in these cars.
Any one last question? Any real quick question for Karl? Yeah, over there.
That would advance the space by a lot, the infrastructure change? Oh, that's a good question.
Like vehicle to infrastructure, wireless technology, things like that? Oh, okay.
Well, so that sounds crazy, but if you look at, development of streets, people used to walk in them a lot when there were a lot of, before the advent of the automobile, and the streetscape changed over time. To be honest with you, I'm pretty small bore in my thinking. I'd love Boston to fix their potholes. The thought experiment doesn't do a whole lot for me because I just know that there's no realistic way that the U.S. does any meaningful movement on improving but also maintaining infrastructure. So we design for the
We
worst
just had
case.
Infrastructure Week. What are you talking about?
Sorry to be a pessimist. But again, boundary conditions. Boston, it's the U.S. infrastructure. Singapore, you have outstanding infrastructure. To be honest, we found that doesn't impact our performance that much. It's the other stuff that's hard. It's the perception, the decision-making, and all the stuff in the natural world, not necessarily the streetscape.
Well, thank you, Karl. You're going to stick around, right, for the rest of the event? Cool. We'll definitely go up and talk to Karl, and thank you very, very much for the time.
Thank you.
All right.